This is the Unit 2 study guide, prepping you guys for the Unit 2 test. So the first section is asking us if it is linear, exponential, or neither. So this first one, because there is an exponent of 2, this is not linear nor exponential. This is neither, which is answer choice C. The second one, because x is in the exponent, this is exponential. We also have our base, our multiplier of 1/2, so this is exponential decay even. As we move down, this one is written in point slope form. So remember, point slope form is y minus y1 equals m times x minus x1. That's straight from your formula sheet, letting you know that this is a linear function, which is answer choice A. Our next one, this is in y equals mx plus b formatting with this y equals 5/9x plus 4. So this is linear. In this section, we have this one. So to go from -5 to +3, we're adding 8. To go from 3 to 11, we are adding 8. To go from 11 to 19, we're adding 8. But the change in y values is not the only part you have to look at. So we also have to look at our change in x. To go from 4 to 5, we add 1. From 5 to 6, we add 1. From 6 to 8, we add 2. So when we're looking at this, we have our first two ordered pairs have a rate of change of 8/1. Our second two ordered pairs have a rate of change of 8/1. But the last two ordered pairs, the change between those last two ordered pairs is 8/2, which is not equal. So therefore, this is not a constant rate of change. It's not going to be a exponential function, because to go from a negative to a positive, you'd have to be multiplying by a negative, which means your term after that positive would also be negative. So this one is neither. Answer choice C. Last but not least, a linear function is a straight line. An exponential function is either a J-curve for exponential growth or a L-curve for exponential decay. So because this one goes up and goes down, this is neither. Answer choice C. So we have mold grows at a rate of 2 centimeters per day. A piece of bread has 5 centimeters of mold on it on day 1. Is the relationship between day and square meters of mold on the bread discrete or continuous? So remember, discrete is something that happens all at once. So if you are having this bacteria grow, that means it doesn't grow until the end of the day. Continuous means that from the moment it starts growing, it continually grows gradually throughout that day until it's reached that amount for the day. So because bacteria doesn't just poof and exist, this is a gradual increase. Therefore, this is continuous. You could stop at any point in the day and measure how much bacteria is on that piece of bread. All values throughout the day make sense. All right. There was a very gracious lady who made clothes for children and was interested in providing clothes to those in need. She started by giving out 4 items of clothing on the first day. So I'm going to go ahead and highlight that because that is important. Each day, she's able to give out 2 more items of clothing to those in need. So each day, she's able to give out 2 more items of clothing. So what is our rate of change? It's the 2. How much do we start with on the first day? And remember, guys, you need to be able to distinguish between the first day and the beginning, that 0 day. So on this one, because, excuse me, because it says 4 items on the first day, next to the 1 is our 4. Then it says she's giving out 2 more each day. So we're adding 2, which gives you 6. Add 2 again. Means she's given out 8. Add 2 again. She's given out 10. So we've taken care of number 8, where it says fill in the table. Number 9 says to complete the graph. So the first thing we need to do is label our axes. So in our x column is the same as the x column from the table, your number of days. And then your y-axis is the same as your y column, the items of clothing given. So as we plot each of these points, we have 1, 4, 2, 6, 3, 8, 4, 10, and we can continue this pattern all the way across the entire graph. So, is the relationship linear or exponential? Because we're adding, it's linear. Is it discrete or continuous? So she's giving out 2 articles of clothes every day. So this is not something that happens gradually throughout the day. Halfway through the day, she's not going to have given out 1. A quarter of the day, she's not going to have given out half of an outfit, or half of an item of clothing. So this is discrete because it's each day she's giving away the 2. It's happening at one point in the day. It's not something gradual. So it says write an equation that shows how many items of clothes were given out. So there's 2 ways that you can write this. We can use our function notation, so f of n equals, and then because we're given the first term, we can do that arithmetic explicit formula straight from your formula sheet. So we have, on the first day, there were 4 items of clothing. Our rate of change is that we're adding 2 times n minus 1. Now, if you wanted to get this into slope-intercept form, and these n's can be x's, it doesn't really matter what your variable is here, being that I was piggybacking on the explicit arithmetic formula, I wanted to have that n value in. So we can also rewrite this into slope-intercept form by converting it into that formula. So we can distribute this 2. So when we distribute this 2, we're left with f of n equals 4. 2 times n is 2n, and 2 times negative 1 is negative 2. So now you can combine your like terms, which are the 4 and the negative 2, because they have no variable, and we're left with f of n equals 2n plus 2. So either of these formulas represent the exact same thing. Just one of them is using the first day amount. And then this one is using the 0 day, which is a hypothetical thing in most cases. Moving on to the back of the worksheet. For questions 13 through 18, let f of x equal 2x plus 6 and g of x equal 4 times 2 to the x. So on this first table, we're looking for f of x. So we're going to use this formula. And then it also gives us values for x. So for each x value, we are plugging that into the formula. So on the first equation, our first evaluation, we have 2. Our x value is 0 plus 6. 2 times 0 is 0 plus 6 is 6. So on our second one, we have 2. Now our x value is 1 plus 6. So 2 times 1 is 2 plus 6 is 8. For our third one, we now have an x value of 2. So we have 2 times 2 is 4, plus 6 is 10. And then for the last x value of 3, we plug in 3 for x, and we have 2 times 3, which is 6, plus 6 is 12. On our next one, we're now using g of x. So when we look at our equations, we have g of x is this one. And our x values are given to us. So each time we have a different x value, we're going to plug it into the exponent. So for the first one, we have 4 times 2, and in the exponent, we're starting off with a 0, which gives us 4. 2 to the 0 is 1. 1 times 4 is 4. So then our next x value, we have 4 times 2. Our next x value is 1. So 2 to the first power is 2, times 4 is 8. And guys, you can use your calculator to plug all of this in and find these values. So if simplifying it using mental math is not your strong point, you may use the calculator. So when we do this one, we have 16. And for the last one, 4 times 2. And our last x value is 3, which gives us 32. So our next one says, complete the graph for f of x. So when we do this, we don't have to label because there's no context on these. So we're simply plotting the ordered pairs. So our first ordered pair, according to the f of x table, is 0, 6. Our second one is 1, 8, then 2, 10, 3, 12. And if we followed that pattern, we would continue up across our graph like this. And then, because there's no context, we cannot tell if there are constraints in this situation, values that don't make sense. And we're adding 2 every single time. We have a constant rate of change, so it is linear. So the next one, complete the graph for g of x. So my first ordered pair is 0, 4, and then 1, 8, 2, 16, and I can't go any further because my next ordered pair is 3, 32. So now I can compare this one, and I see that it has a slight curve about it. This one is also exponential because your multiplier is 2. Your base, always your multiplier is your base value. So in this case, it's 2. So now it says, use the graph at the right to answer questions 19 through 21. So is the function linear or exponential? It's a straight line, therefore this one is linear. Is the function discrete or continuous? Because the points that make up this line are connected, it is continuous. The domain of the function. So this graph has arrows on both ends. Domain is your x values. So it tells us how far left and how far right. So because there's arrows on the left side and the right side of our graph, we know that this domain is from negative infinity to positive infinity, which is also known as all real numbers. So then it asks about the range. So the range is your y values, and it tells us how far down to how far up. So again, there's an arrow on that lower side, so it's pointing down, which means it goes towards the negative numbers for infinity. And then the arrow on the right, the arrow is also pointing up, which means it's going up to infinity. And remember, on negative infinity and positive infinities, we use the parentheses, because we cannot reach infinity. So on the next page, it says write the slope-intercept form and find the x and y intercepts for each of the following. So on the first one, we are given two ordered pairs. So we're going to find our slope first. So we have m equals your change in y divided by change in x. So x1, y1, x2, y2. And straight from your formula sheet, it tells us that to find the slope, we do y2 minus y1 over x2 minus x1. So if you plug this in the calculator, or if you do mental math, you end up with negative 16 over 4, which is equal to negative 4. So now we have our slope. Now we can use one of those points to plug it into point-slope form and then transition it into slope-intercept form. So I'm going to choose the first ordered pair because it's already labeled with x1, y1, and that's how my formula is labeled. So to fill in our formula, we have y minus y1 equals m times x minus x1. So we already know that our slope is negative 4. And we know that our ordered pair, the y1 is 4. And our x1 is 2. So that's point slope form. Now we can distribute that negative 4 and then isolate y to get this into slope intercept form. So we're going to do negative 4 times x and negative 4 times negative 2 in order to distribute that negative 4, which leaves us with y minus 4 equals negative 4x plus 8. So then the last step is to isolate y. So we add 4 on both sides, and remember to line up your like terms. And we're left with y equals negative 4x. 8 plus 4 is 12. So up here where it says equation, we want to go ahead and transfer that. So we have y equals negative 4x plus 12. So for our x-intercept and our y-intercept, with an x-intercept, the y value is 0. For a y-intercept, the x value is 0. So I'm going to go ahead and start there with my ordered pairs. So for an x-intercept, I'm plugging in 0 for y and solving for x. So I have plug in 0 for y, and then I'm going to solve for x. So to solve for x, I'm going to subtract 12 on each side, and then I'm left with negative 12 equals negative 4x. Divide by negative 4 on both sides, and 3 equals x. So that means I'm going to plug in a 3 right here, and my x-intercept is 3, 0. So then your y-intercept. Y-intercept is straight from your slope-intercept form, but I also want to show you guys how it works. So we say the x value is 0 when we're talking about a y-intercept. So negative 4 times 0 is 0. And all we're left with is y equals 12. So that's your y-intercept, 0, 12. So now when we're looking at a graph, things are a little bit easier. Remember, every time you're given a graph, there's two things you need to identify for slope-intercept form, and that's your slope and your y-intercept. So our y-intercept is right here at positive 4. And then our slope, it already has 2 points labeled for us, so we're going to use those. So there are 1, 2, 3, 4, 5, 6 boxes up, 1, 2, 3 to the right. So when you go up into the right, it's a positive slope. We rose 6, we ran 3. 6 divided by 3 is 2. So now we can go ahead and plug this into our slope-intercept form. So we have y equals 2x and your b value is a positive 4. Now, because we have a graph on this one, we can actually see our intercepts. So the x-intercept is where your line crosses the x-axis. So this one is at -2. So in an x-intercept, your y value is 0. So we write this one -2, 0. And then the y-intercept is already written. We've written it out. Now we just have to convert it to an ordered pair. So in a y-intercept, x is 0, and your y value gets the number. And the last one, we have to convert this from standard form into slope-intercept form first. So the steps for doing that are to move x and its coefficient. So we're going to subtract 6x from both sides. So 6x minus 6x is 0. And we're left with -3y equals, and I like to put my x values first, so I'm going to put the -6x, then the -12. So the last step is to divide by y's coefficient, divide all terms by y's coefficient, and we're left with y equals -6x divided by -3 is 2x. -12 divided by -3 is +4. So we can go back to the top where it asks for the equation and put y equals 2x plus 4. So I'm going to go back to standard form for finding this x and y intercept. So remember, with an x-intercept, the y value is 0. So when I solve for that, if this y value right here is 0, that gives me -3 times 0, which means it's just not there. It goes away because that multiplier of 0 makes the entire term a 0. So what that looks like written out is 6x minus 3 times 0 equals -12. So we plugged in a 0 for y. So -3 times 0 is 0, and we're left with 6x equals -12. To finish solving this, you divide by 6 to isolate the x, and we're left with x equals -2. So that's our x-intercept. So when we come up here, we have -2, 0. So on a y-intercept, the x value is 0. So when we look at our standard form, now we're talking about the x value would be 0. So we have 6 times 0 minus 3y equals -12. 6 times 0 is 0, which leaves us with -3y equals -12. When you divide by y's coefficient of -3, you end up with y equals 4. So that's your y-intercept. X is 0, y is 4. So on the next one, it says compare the functions to determine which has the greater rate of change. So I'm going to underline greater because that's our big hint of what we're looking for. So on this first one, I see that we're going from 4 to 12 to 36. To go from 4 to 12, I can add 8, but adding 8 doesn't work the whole way through. So another way to do this one is to multiply by 3, which does work. You still have to check your left side, your x values. So these x values are going up by 1 every time, which lets me know that my rate of change is this multiply by 3. So for function A, it's multiply by 3. For function B, remember your multiplier is your base. So the base in this one is the 4. So which one has the greater rate of change? Function B. There we go. All right, on the next one, we have this graph. So this increases by 6 over 3. So because it's up and to the right is a positive slope, our slope is 6/3 for our rise over run, which is equal to 2. And because this is linear, we know we're adding 2 through the whole thing. So on function b, our slope is the -4. So remember, positive and negative tell you the direction of the line. The steepness is represented by the number. So a line with a slope of 2 is less steep than a line with a slope of -4. So function b has the greater rate of change because it's a steeper line. Last one. Janet wants to know how many seats are in each row of the theater. Jamal lets her know that each row has 3 seats more than the row in front of it. The first row has 10 seats. So our keywords here, each row has 3 seats more. So that lets us know that we're adding 3 seats for each row. On this second, function b, to go from 5 to -1, I add 4. To go from -1 to 3, I add 4. Remember, you have to check your x values as well. To go from 2 to 3, we add 1, and from 3 to 4, we add 1. So this means that function b has a rate of change of 4/1, which is equal to 4. So when we compare it to function A has a rate of change of 3, function B has a rate of change of 4. So therefore, yet again, function B has the greater rate of change. So on to the next one. We have write the exponential function that passes through 0, 2, and 4, 512. And it gives us this hint to make a table. So we have 0, 2, have 1 something, 2 something, 3 something, 4, 512. So because this is exponential, we know we're going to be multiplying by something. So we're going to say we multiply by r to get from the 0 term to the first term. We multiply by r again to get to the second term, times r again to get to the third term, and times r to get to 512. So we start at the 2. We multiply by r 4 times. Remember, repeated multiplication is represented by an exponent, and that takes us to 512. So to solve this, divide by 2, and then we have r to the 4th equals 256. Then using your calculator, we're looking for the 4th root, which means you would hit 4 second, then the caret, and then type your 256 and hit enter. So that's how you find your 4th root, is by pushing this combination of buttons. And you find out that r equals 4. So 4 times 4 times 4 times 4 is 256. So it wants us to write the exponential function. So we're not finished yet. So we still have to go back and write our equation. So we have y equals a times b to the x. Remember, a is your y-intercept, which is 2. Your multiplier is represented by b, your base. And then because it's exponential, x is in the exponent. X in the exponent for exponential. All right, next one. You start your bank account to save money for the new car. Oh, and I forgot. We could also write the 0 term formula on, or the first term formula on this one. So if you wanted to find your first term, you would multiply by your ratio and get 8. And then you could also write y equals 8 times 4 to the x minus 1, just like we did with the geometric sequences, where we used our first term and our common ratio to write our formulas. So either of those are fine. So moving on to the next one. You start your bank account to save money for the new car you need with $150. Each month, you put in $300. You need to save up $3,750 to buy this car. So the equation for the car. The things you need to know is that you start your bank account with $150. Then it says each month you put in $300. So that's your hint that that's the rate of change. So we have y equals your rate of change is the 300. Rate of change is always touching x. And you begin with $150. So the domain in words. Remember, domain is your x values. So in words, this x, the x touching that 300 is the months. So if you go back to your word problem and find that 300, it's included in that highlight that says each month you put in $300. So the 300 is the $300. The x is the number of months. So as an interval, you have from month 0 to some other month that it takes you to get $3,750. So this is where we actually have to do a little calculation. So we know our total amount is $3,750. And we're getting that $3,750 by depositing $300 a month to the $150 we began with. So to solve this, you subtract the 150. 150 minus 150 is 0, which is why that cancels out. And then we're left with 3,600 equals 300x. So when you divide both sides by 300, since we're trying to isolate the x, we're left with 12. So that being said, it's going to take 12 months on that current pattern of adding $300 every month in order for you to have the full $3,750 needed to buy that car. So our interval is going to be from 0 to 12. We use the hard brackets because those amounts exist in our problem. You can pay for 0 months, you can pay for 12 months. So the inequality, since we're talking about the x values, x is what goes in the middle. The smallest value is 0, and the largest value is 12. So in set notation, this is where we look at the discrete function. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the reason I wanted to list all of those out is because it doesn't go past 12. So if I put the dot, 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 it makes it look like it goes to infinity. So I listed all of them out. Now our range values in words. So if x is the number of months, our range values, our y values, is the amount of money saved. So in an interval, you begin with $150. So you begin with $150. You have $150, so we use those hard brackets because that value is in your range. So the maximum amount you need is that $3,750. So as an inequality, 150 is the lowest amount you have. We're talking about our y values this time, and 3,750 is the maximum needed. So as set notation, you have $150 in the beginning. You're adding $300 every month for 12 months. So 150 plus 300 would give you 450 plus 300, 750 plus 300, 1,050, 1,350, 1,650, 1,950. I'm going to write on the second row because this is a lot more to write. 2,250, 2,550, 2,850, 3,150, 3,450, and 3,750.